Good evening, ma'am.
Good evening, ma'am.
Good evening, ma'am. Good evening, ma'am.
Good evening, everyone.
Good evening, ma'am.
Turn on your cameras.
Good evening, ma'am.
Good evening. Turn on your cameras, everyone.
Ma'am, have you corrected our subjective test papers?
Yeah, the marks have been uploaded.
Okay, I'm like I haven't checked it. I'll check.
Please, everyone, come on the cameras. And who will tell me what are mixtures and what are its types?
Ma'am, what are?
Mixtures. Mixtures. That was your homework. Elements. Okay. First, tell me the difference between elements and compounds. Advika, Rishit, Ashwath, Riyansh, and Aishwarya. Turn on your cameras.
Ma'am, my camera is not working. Ma'am, can I tell?
Who's this?
Ma'am, DBS.
Okay.
Ma'am, elements are made out of same type of atoms and the compounds are made of like different types of atoms on the ratio.
In a definite proportion. State examples. Anyone else, not Ishwarya. Anyone else will state example.
Ma'am, sodium, carbon, for potassium. Ma'am, for element. Carbon.
Correct. And compounds?
Ma'am, compound. Ma'am, water.
Formula of water?
Ma'am,
H2.
H2O.
sodium chloride.
So,
Sodium. Carbon dioxide.
okay. Sriyansh, in water, which elements are used in formation of water?
Ma'am, oxygen.
Two
Only
H2
oxygen?
and one oxygen. So
One atom of oxygen and
Oxygen and hydrogen. In what proportion they are present? What is the ratio?
I don't remember that.
Ma'am, only one.
One of what?
Oxygen and two hydrogen.
Ashwath, give chance to others also, please. Everyone is supposed to turn on the camera. Charvik, Siddhant, Sriyansh, Aishwarya, quickly. Rishit,
Yes.
which elements form the formula of table salt? Sodium chloride. Which two elements?
Ma'am, Na and Cl.
Na and
Cl.
what is the ratio?
Ma'am, I don't know the ratio.
If I tell you the formula, then you have to tell. The formula is NaCl. Okay, wait, let me share the screen. Okay, you all are supposed to tell me the ratio of elements in these compounds. Okay. See, every symbol of element starts with a capital letter. So if I've written Na and N is caps, so means Na is a single element, symbol for single element, and C again is caps, so Cl combinedly is another single element. Two elements are used here. Tell me how many atoms of Na and Cl are used?
Ma'am, one atom of Na and one atom of chlorine.
Okay. Chlorine. Sodium and chlorine separately will be called elements, but when single atoms of each of these combine, then it becomes a compound. Okay,
Ma'am, so is the ratio 1:1?
1:1, yeah.
Okay.
Next,
I'm sure it's sodium chlorine.
sodium, no, the name becomes sodium chloride. Actually, when we combine different elements, the names changes a bit, like sodium chlorine, it will not be sodium chlorine, but sodium chloride. Okay, that's okay. If I'm giving you the formula, you need not to remember the
Like,
name.
are you taking the atomicity level here?
Hmm?
Are you taking the number of atoms like atomicity?
You have to tell me the number of atoms.
No, like I'm asking, are you taking the atomicity, like the number of atoms? Atomicity.
Yeah.
Okay.
So if anyone knows what is the formula of ozone layer, that is in protection, that is
O3.
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 Okay. So how many atoms of oxygen are present here?
Three.
Three.
Okay, so that ozone layer itself is not an element, it is a compound formed of 3 atoms of oxygen. Okay, it will not be called as compound, I guess, because 3 atoms of oxygen only are required. That's fine. Give me a minute. Have you heard of hydrochloric acid?
Yes, ma'am.
Yes,
HCl.
ma'am.
HCl.
HCl.
Hydrochlor.
HCl.
Hydrogen plus chloride.
Hydrogen plus chlorine.
Plus chlorine.
And again, single atom each of hydrogen and chlorine. Okay, so I hope you have understood what are compounds, where different elements are present in fixed proportion. Those are known as compounds.
Yes, ma'am.
Clear? Now we have to move to mixtures, because often children get confused between compounds and mixtures. Just give me a minute. If anyone can tell me what are mixtures?
Ma'am, they're not like, they don't have a definite proportion.
Write on the definition of mixtures. It is a physical combination. It is a physical combination of two or more substances. A physical combination of two or more substances that are not chemically joined. That are not chemically joined.
One can repeat from start.
Mixtures are a physical combination. Sorry. Mixtures are physical combination
After that,
or more substances that are not chemically joined and can retain their identities. And can retain their identities. Noted?
Yes, ma'am.
So now can you give me the example of this mixtures? Take the example of mixtures. Quickly, anyone?
Sugar plus water.
Sugar plus water, sugar solution, correct?
Iron oxide.
Salt and water, sand and water.
Iron oxide.
Ma'am, lemon and water.
Iron oxide is not a mixture, it is a compound.
Salt and water,
Salt and water.
sand and water.
If you mix oil in the salt, whenever we are cooking, making a lemonade, baking a cake, all those quantities are not in definite proportion. We mix just as per the idea. So all the things that we cook or prepare can be called as mixtures. Okay. Like
Is yeast mixture.
like seawater. Seawater is also a mixture because it is fully filled with the minerals and salt and many other dust particles. So that is also a mixture.
Yeast.
Ma'am, dirt and water.
Mixture yeast.
Dust and water. Yeah, dirt and water, correct.
Yeast.
Yeast.
Salt and water.
Mm, now yeast cannot be called as a mixture.
Ma'am, cocoa.
And like, can a dough
Ma'am,
like
oxygen
when
and
we add-
water.
like when we add
Oxygen. If there is no definite proportion or no ratio, if we are mixing any of the elements, 2 or more, then it will be termed as mixture. Okay. Now anybody.
It is almost same like compounds, ma'am.
Pardon?
It is almost same as compounds, ma'am.
Almost same as compounds, you are telling?
Yes, ma'am. Mixtures.
You cannot say almost same. There's a big difference. Compounds has a definite proportion that clearly visible here, and mixtures we are telling if you mix sugar in the milk, if you mix lemon in water, all these are examples of mixture. Okay. Now we have to make a table, and let's differentiate between the types of mixtures. So just divide into 2 categories. First, write homogeneous, and next is heterogeneous. Please note down. Should I tell you the points now? Children, should I tell you the points to write? Write the first point in homogeneous. They have uniform composition. They have uniform composition throughout the mixture. They have a uniform composition throughout the mixture. And in heterogeneous, write the corresponding point that they have a non-uniform composition, or you can write they have a mixed composition which may vary.
Ma'am, they have in homogeneous, they have uniform.
Uniform composition. And heterogeneous has mixed composition or non-uniform composition, whichever is easy for you to understand.
Ma'am, and heterogeneous mix.
Mixed.
Ma'am, can you repeat the heterogeneous?
heterogeneous mixtures have a non-uniform composition, or heterogeneous mixtures have mixed composition, which may vary from point to point. Is it okay?
Yes, ma'am.
Or do one
Ma'am,
thing.
can you write on the board?
Hmm?
Can you write on the board?
Okay, okay. Let me clear it out first. Just hold on. Hmm. Give me a minute. I'll tell you the properties on basis of which you have to write the So first comparison was based on composition. You can just add a column here. Okay, composition, homogeneous, heterogeneous. Sorry, uniform and non-uniform. Okay, next point, write down particle distribution. Particle distribution. Now write down homogeneous. In homogeneous, it is even, and in heterogeneous, it is uneven.
Ma'am, like what is composition unique?
Composition means like suppose we are mixing salt in water. So after stirring it for some time, the salt will be, you can say, evenly distributed. The
Means like
composition
what is unique?
in
UNM.
any quantity of that salt solution, you will find equal amount of salt. If you take, same amount of volume and want to measure how much salt it contains, then you will find same amount of salt in same amount of solution. Got it?
Okay,
But
ma'am,
this
I'm
once I'll give you
asking, ma'am, I'm asking what does it mean unique? UNI.
oh, dear, that is uniform. Haven't you written uniform? Same. Is it clear now?
Yes.
Next is size of particles. Just give me a minute. In size of particles, write smaller and heterogeneous is larger. Okay. Further, I'm writing the points of comparison. Stability. Next is solvation. No, just write down particles. Example. Try to think what about the stability and particles and examples of these.
Ma'am, you're on mute.
Yeah. What about the stability? See, whether these points of composition and particle distribution, do you think the homogeneous will be stable?
Yes.
ma'am, they will be stable. Ma'am, due to its uniform composition.
Particles are not visible. Particles are not visible in homogeneous mixture, and in heterogeneous, they are mostly visible. Suppose if you mix chalk into water, after leaving it undisturbed for some time, you'll notice that chalk particles will settle down. Such type of mixtures are called heterogeneous. Okay. Examples, generally you can write solutions, and generally you can use the word suspension. So state examples of homogeneous and heterogeneous. Based on these properties, at least you can tell.
Ma'am, what do you mean by suspension and the heterogeneous?
Wait. Sorry. Write here sugar and write here sand plus water. I hope you must have understood a bit. To state more examples. Next example. State next example.
Ma'am, salt and water?
Salt and water again is homogeneous, correct?
Ma'am, is Coca-Cola mixture?
Okay. Homogeneous, correct? More, lime juice in water and honey in milk. These are all homogeneous mixtures. What happened? You can say rainwater also coming out of the kitchen. Rainwater or the substances which are used to make vinegar means we
Dish what
see.
in ma'am dish? Ma'am, homogeneous can we say like uh, sugar water? Like
Yeah. So
see,
homogeneous basically means
mouthwash or
yeah,
detergent.
anything which you perceive as a single type of substance. We know that it consists of many ingredients, but we perceive them as single type of substance will be termed as homogeneous. In which,
Okay.
by just looking at that, we cannot identify what all ingredients are present. We cannot see the ingredients separately. That mixtures are homogeneous mixtures.
Okay, ma'am.
Understood?
Okay, yes, ma'am.
And give state examples of heterogeneous now. Suppose
Chalk in water?
chalk in water is already there. Sand in water is example of heterogeneous. More. If suppose you mix salt and sand, that is also heterogeneous mixture. So the mixture in which you can see, means by just looking at it, you can see it contains these substances, these
oil in
substances
water.
and all. Those are heterogeneous.
Ma'am, oil in water.
Oil in water, correct.
Ma'am, stones in water.
Lemon in water, squeezing lemon juice in water is homogeneous,
Yes,
and lemon in water is heterogeneous.
okay.
Ma'am, stones in water.
Hmm?
Means like stones in water. Stones.
Stones in water, yeah, pebbles in water, that all heterogeneous mixtures.
And so like insoluble mixtures are known as heterogeneous, right?
Yes, yes. That's why the general word used for the heterogeneous mixtures is suspension.
Okay.
Okay. Should we proceed?
Yes.
Ma'am, can you repeat why it is used suspension? Why is suspension used?
Anything in which one or the other component remains suspended, and you can perceive them separately, distinctly in the mixture, then it will be a heterogeneous mixture.
Okay.
Give me a minute, please.
Ma'am, can you give one more example for heterogeneous?
Aishwarya, I cannot hear you clearly. Please repeat.
Can you give one more example for heterogeneous?
For heterogeneous, give me a minute. Milk and tea leaves. Milk and tea leaves. Okay.
Okay.
And another more example of homogeneous is alloys. Means if I say iron is a distinct element, means but pure metal. Copper is a pure metal, but alloy means steel. Most of the utensils in our kitchen are made up of steel, and that too stainless steel. Okay, so steel is not an element, it is a mixture of some amount of chromium, some amount of nickel, some amount of carbon and iron. That alloys we cannot see, we perceive the material as whole one type of substance. It is visible to us as a single type of substance. So alloys are a very good example of homogeneous mixtures. Got it? Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yeah, so mixture is all done. Now let's move to chemical equations. Who will read chemical equations? Who will read out chemical equation once loudly?
Ma'am, can I read Rishit?
Advika.
Yes, ma'am.
Please read chemical equation.
A chemical change resulting in the formation of one or more new substances is called a chemical reaction. The representation of a chemical reaction using symbols and formulae of the elements or compounds involved in the reaction is known as a chemical reaction. The chemical substances that participate in a chemical reaction are known as reactants. The new substance formed due to a chemical reaction are known as products. For example, consider the reaction of magnesium with oxide. Oxygen. Magnesium reacts with oxygen to form magnesium oxide.
Correct. So all the chemical changes that we have learned are due to the interaction between the atoms and molecules of two different elements, okay, where the chemical change resulting in the formation of one or more new substances is called a reaction. And as we have seen earlier also, I told you the reaction of calcium oxide with water forms calcium hydroxide. If you remember, CaOH whole twice. So we cannot write the complete names of elements repeatedly one and other times again. That's why means they have converted into symbol form, and every element's symbol starts with a capital letter. Some have, mostly elements have two letters only, either one or two. If single, it will be a caps lock, and if two, first letter should be, first alphabet should be capital always, okay. So the chemical substances that participate in chemical reaction are known as reactants. That is, any substance that we write on the left side of arrow are reactants, which are actually reacting together. And on the right side of arrow that we got as product or products. If one product and products. So for example, burning of magnesium ribbon is given here. You can note this down.
Chemical equation.
Hmm?
Ma'am, what is chemical equation?
Ashwath.
Yes, ma'am.
Okay. Suppose, although we already have water, but we can prepare it in the laboratory, although much of efforts will be required. Suppose you separately have hydrogen element, you separately have oxygen element. Okay. If you combine hydrogen and oxygen separately together, you will get H2O. Got it? So when we combine different elements and they react to give us a product, this is known as a chemical reaction. Okay, let me take simple example. Suppose I asked you to cook. I asked you to cook potato veggie. Okay, what you will do? You will just peel the potatoes off and boil them, and then add some spices to them, add some water to them. It will get cooked. So can you get that the cooked potato in the same raw form as it were earlier?
No, ma'am.
So whatever changes you have made, you have added spices, you have added water, you have provided heat energy to water. All these things have undergone a reaction. So potato has been, their chemical composition of potato has been changed, and they have become soft and spicy, and we can taste it well. Means one cannot eat the raw potato, but one can easily eat and digest the cooked potato. Got it? Understood?
Yes, ma'am.
So any substance which undergoes a chemical reaction means all of their compositions have actually been changed. So earlier we have learned now what are the signs or symbols of chemical equation. How can we know that it is a chemical equation or it is a chemical change? If you means the symbols can be, there can be change of odor, means smell, change of taste, or evolution of gas, absorption or release of energy, precipitate formation. All these are examples, all these are signs or symbols that you have made something or some substances have undergone a chemical change. So when we express that change by the help of symbols, it is termed as chemical equation.
Okay.
Any doubt, anyone now? Anyone? Is there still any doubt?
No, ma'am.
Just a minute. Okay. Okay. Now, can anyone explain what do you mean by rusting of iron properly?
Ma'am, when oxygen and water get in contact with the iron, like it rusts.
Only oxygen and water. Only the attack of oxygen and water is makes the rust.
Ma'am, when iron is exposed to moisture or air like oxygen or water vapor, it creates a brown rust, and that's how called rust on the iron.
Okay. And any idea about galvanization? Galvanization? No. Okay. Well, whatever topics we have covered in this chapter, please revise them properly for the upcoming test. Okay. Because MCQs are a bit hard. We have a number of choices. So prepare the chapter well this time. And
Ma'am, have you told about galvanization something just
no, I haven't told you about, but I was asking because if anyone have the idea about it, that will be great.
Ma'am, I heard it. Ma'am, I heard about it. Like, is
I'm
it
like I
like
heard it.
Actually,
Galvanization.
Ma'am, I
can
think
give
it
you
is
the
the
This is the
process
process
of
of applying
preventing
a protective
iron
film
from
coating
rusting.
in your
It
iron.
is
Yeah.
one
To
of the
prevent rusting.
process. Listen, it is one of the process to prevent rusting of iron or simply corrosion of metals. Okay, so get information. The homework is to get information about the corrosion of metals, the degradation of metals. Usually, what metals are used in home? Iron, copper, gold, silver. These four are very common and you can definitely find it in your home. So whenever you observe any change in their color with time, that is known as corrosion. Okay, so find out how they get corroded and suppose silver degradation. So with time, what colored layer accumulates on silver, what uh, color changes observed in gold ornaments, because gold and silver we usually as ornaments. Okay, copper and iron you can find in your kitchen. So this is your homework. Okay, fine, bye bye. We'll meet in the next class.
Bye, ma'am.